Hi, and welcome to 12.1 Magnetic Field Lines. It's not going to get too crazy in this class. We're not going to deal with a whole lot of equations when dealing with magnets, but the magnetic field lines, while maybe they seem pretty easy at first, a lot of people have made a lot of different multiple choice questions to try to trick you. So you have to just read them carefully and remember the lines go out of north and into south, and the closer the lines are to each other, the stronger the field. So let's get started. Number one, it says the diagram below represents the magnetic field lines of a magnetic lines of force around a bar magnet. At which point is the magnitude of the magnetic field the strength of the bar magnet the greatest? You're just looking for where are the lines the closest. That's it's the lines are like a model for how to represent the field around an object. It's not like only the field is in this particular line. Oh, there's a field right there, but nothing over here. That's not how the model works. It's a region, so the magnetic field is everywhere, but it's hard to draw a whole region. Like you would have to like shade in darker here, and then it gets lighter as you go out. All right, and that's kind of difficult to do. Not everybody's an artist, so they came up with this way of drawing magnetic field lines to represent that field and how it's stronger where the lines are closer. So basically, the whole thing arose because people don't know how to do art. All right, so you're looking for where are the lines the closest. We're gonna say A. The lines are closest right here. And kind of by definition, for bar magnets, you could remember the field is strongest near the poles on either side. That's something else you could kind of remember. All right, so number two, same concept. Where is the field the strongest? Wherever the lines are closest to each other, that's going to be choice C right here. The lines all start kind of like moving towards each other here, meaning that the field is stronger at that position. A lot of people try to pick B because they're like, oh, well, B is right on the line. So isn't the field the strongest right on the line? As I said before, the lines are just a model to help describe the field. It's not like the field is only along the line and it's not anywhere else. It's a region. The whole region is the magnetic field, and the closer the lines are to each other, the stronger the field is. Kind of a weird concept. Number three, similar idea. At which point is the magnetic field the greatest? Wherever the lines are closest together, and that's going to be inside this piece of iron. So it's choice C. And number four, maybe a little different of a concept. It says the diagram below shows the magnetic field lines between two magnetic poles A and B. Which statement describes the polarity of magnetic poles A and B? Remember, they go out of north and into south. So the lines are all coming out of A, this is north, and they go into B. So that's south. So it's going to be choice A. A is a north pole and B is a south pole. All right. This one's classic. It says when two ring magnets are placed on a pencil, magnet A remains suspended above magnet B as shown below. Which statement describes the gravitational force and the magnetic force acting on magnet A due to magnet B? So now they're bringing gravitation into it. And unlike magnetism, gravitational forces are always attractive. So B cannot be. And it can't be D either because that's saying that the gravitational force is repulsive. You're always attracted due to gravity. Anything with mass is going to attract another thing with mass. Gravity never repels things away, all right, which is good. But magnets are a little different. You can attract or you can repel. And since A is like hovering above B, that's telling me that the two magnets are repelling each other. So the magnetic force is repulsive. That's going to be choice A. Number six, it says at which point in the magnetic field, at which point is the magnetic field strength the greatest? Again, you could say where the lines are closest to each other, or since we're looking at like two pieces of a bar magnet here, you could say wherever it's closest to the pole, and that's going to be choice B. Okay, the closer you are to the poles, the stronger the field. The closer the lines are to each other, also the stronger the field. Here's where it starts getting tricky when they start talking about compasses. So in a compass, Okay, you have a little needle here, and the needle always points towards north. Well, geographical north, right? So uh, this is the north side of this little needle, and this is the south side of the little needle. Okay, but the way the Earth works is the gravitational. Let me see. Let me draw it like this. Let me draw the Earth. What a great Earth that is. Very nice. And then, so we have obviously like the North Pole where Santa lives is here, and the South Pole is here. Okay. But what about if you have a compass? So here's our compass, and here's our compass needle. And the red side, or the shaded inside, is always the north side. So the way compasses work is the north end of a magnet, all right, points towards north. But wait a second. If this is north here, this is north, how is north attracted to north? It points towards north, so it must be attracted towards the north, right? I thought north is repelled by north. What the heck is happening here? Well, the geographic poles are opposite of what the actual magnetic poles are. So we have the black lettering says the geographic North Pole and geographic South Pole. And if the Earth is a bar magnet, then which side is north? Is the top or the bottom north? Well, if the north end of this compass needle is pointing up, that means the top of it must be the southern side of the magnet. And here, this is north. So this is the magnetic north is in geographic south, and magnetic south is in geographic north. And now hopefully it makes sense why the north end of a compass needle is attracted towards the magnetic south pole, which is the geographic north pole. So it gets a little confusing. This is like one of the classic ways they could try to trick you with this seemingly straightforward concept. So let's read the question now. Hopefully it'll make more sense. It says the diagram below represents the magnetic field near point P. So here the field is going out of north and into south. So this is magnetic north, and this is the magnetic south field there. It says if a compass is placed at point P in the same plane as the magnetic field, which arrow best represents the direction the north end of the compass needle will point? So here's our compass. Oh, let me make it so point P is in the middle. Kind of, maybe. All right. And we know it's going to like align itself, but which direction is the north end going to point? So we said the north end is typically red. Is the north end going to be attracted to the north, or is the north end going to be attracted to the south? To me, this makes it look like it makes more sense. So we have the north end right here pointing towards the south. And how did I figure out that was south? Because the lines point from out of north into south. So I looked at the direction the lines were pointing, and they were going out of the northern side and into the southern side. So that tells me south is right here. And then it's saying, where is the north end of the compass needle going to point? Well, north is attracted to south, just like that. Okay, so we know it's going to be choice B. Kind of tricky, kind of tricky. Okay, so let's see. 8. The diagram below shows a bar magnet. Which arrow best represents the direction of the compass needle, of the needle of a compass placed at point A? So you have to know the needle of the compass is where the north end is. That's kind of why I put 7 before 8, because this tells you, it reminds you the north end of the compass needle is the thing that points, right? So let's see. Hopefully you could determine that the compass needle itself will be like aligned with the field this way. One side's going to be attracted towards the north, one side's going to be attracted towards the south. So the southern side of the needle will be attracted towards the north, and the northern side of the compass needle will be attracted towards the south. And that's what we're really looking for, is what direction is north going to face? North points towards the right. North points towards the southern side of that compass needle. All right, so it's saying where is it pointing? It's like, well, where is north going to be attracted to? North's going to be attracted to this southern side of the bar magnet. So it's going to be choice C. Number 9, which diagram below represents the magnetic field near a bar magnet? Just refer back. Sometimes you could do this. This is a pro tip for when you're taking tests. I'm sure you already figured that out by now. But it tells you in a previous question, it shows you what the diagram looks like, right? So you could eliminate C and D. Why is C and D no good? They look similar to some diagrams we might have seen in the past. Well, the rule is it has to go out of north and into south. So yeah, it's coming out of north here, but it's also coming out of south for this one. So this one definitely doesn't make sense because it's going out of south. The magnetic field lines have to go out of north into south. They're going into south here, so that's good, but they're going into north here, so that's no good. We want out of north into south. So which one is showing that? A or B? Out of north into south? That's B. They go out of the north and into the south. Just like that. Okay, A is opposite. And I think that's it. All right. Have a great day.